What does it really mean for an AI to think? Today, we're diving deep into Interview.net Solular Architect scenarios. The .NET ecosystem has transformed cloud-native microservices, AI/ML integration, edge computing. Solution architects must design systems that scale, evolve, and integrate across heterogeneous environments. Yet, hiring processes remain stuck in syntax and trivia, not architectural depth. Scenario driven evaluation is the industry's overdue response to this complexity. This keynote presents a structured, repeatable system to assess .NET architecture competence. The strategic imperative: hire architects who can navigate real world design tensions, battle tested methodology. But here's where it gets interesting: the architecture blind spot. Conventional .NET interviews evaluate coding speed, API recall, and algorithm puzzles. They fail to probe system design, evolutionary architecture, or cross-functional trade-offs. Senior candidates recite patterns without defending them under constraint changes. Unvalidated architecture skills result in brittle systems, costly rework, and missed deadlines. The average cost of a mishired solution architect exceeds $150K in direct and opportunity losses. The industry's blind spot: architecture judgment is assumed, not tested. Architecture failures in production are 10x more expensive than coding bugs. Most formats are non-differentiating for senior architecture roles. So what's the real problem? Let's talk about root cause: texting recall, not reasoning. Architecture is a decision discipline, not a knowledge checklist. Traditional formats isolate questions. Real architecture is a continuous negotiation of trade-offs. Interviews lack dynamic constraints, no evolving requirements, no production incidents, no stakeholder conflict. Candidates perform pattern matching, not deep system thinking. The format itself discourages the cognitive load required for architectural reasoning. This misalignment leads to architectural mismatch hires that erode team velocity and morale. Candidates are rarely asked to navigate uncertainty, only to confirm known patterns. This raises a critical question: breakthrough, synergy-driven architecture evaluation. We engineered immersive, evolving architecture challenges specific to the .NET landscape. Each scenario simulates a real business problem: e-commerce scale, healthcare compliance, fintech transactions. Candidates design, defend, and adapt their solution in real time as constraints shift mid-session. The method reveals trade-off logic, technology selection criteria, communication under pressure. Evaluation shifts from answer correctness to reasoning quality, resilience, and adaptability. This is the closest proxy to on-the-job architecture performance, validated across dozens of hiring cycles. Scenario sessions are recorded for calibration and continuous improvement of the evaluation model. 3x predictive validity over conventional tech interviews. Now let's zoom in on system. The architecture assessment framework, a multi-layer evaluation model spanning domain design, application architecture, infrastructure, and observability. Layers: domain complexity, application patterns, distributed systems, cloud infrastructure, security, and observability. Each layer includes a library of parameterized scenarios: transaction volume, latency SLO, data consistency level. The scenarios map to role seniority, from staff architect to principal. The framework provides a consistent, repeatable scoring rubric, eliminating interviewer bias. It integrates with existing hiring pipelines and can be delivered on-site or remote. The system supports both live and asynchronous evaluation modes. Calibration sessions using reference answers maintain scoring consistency over time. Here's something most people overlook. Comment 1. Domain-driven design scenarios assesses the ability to decompose complex domains into bounded contexts and aggregates. Scenarios, legacy monolith decomposition, multi-tenant SaaS partitioning, event-driven supply chain. .NET tooling, EF Core, Mediator, Mass Transit, Azure Service Bus Depper. Key decisions, aggregate boundaries, eventual versus transactional consistency, event choreography versus orchestration, evaluation criteria, model expressiveness, alignment with business invariance, change flexibility. Candidates must document their design rationale and respond to a sudden domain rule change. Candidates produce architecture diagrams, sequence flows, and decision records during the session. Scenario difficulty adjusts based on candidate performance in earlier phases. Think about this for a second. Component 2, distributed system S and integration patterns. Evaluate service communication design, REST, gRPC, GraphQL, message brokers, RabbitMQ, Kafka. Scenarios introduce failure, network partitions, cascading latency, duplicate events, .NET Resilience Stack, Poly, Retry, Circuit Breaker, Saga's Outbox Pattern. Candidates choose between orchestration, Azure Durable Functions, and choreography, Event Bus. Decision drivers, coupling, observability, operational complexity. Assessment measures fault tolerance design, idempotency guarantees, and scalability bottlenecks. Also evaluates API versioning, backwards compatibility, and contract testing strategies. Scenarios include legacy system integration, requiring strangler fig pattern and data sync strategies. And this is where things get complex. Component 3, the security, performance, and observability. Cross-cutting scenarios demand architectural governance, not afterthought implementation. Security, OAuth 2, AutoWIC ID Connect flows, API gateway security, data encryption, zero trust principles, performance caching hierarchies, Redis CDN, database indexing query tuning, async/wait pitfalls. Observability, open telemetry for traces, metrics, locks, health checks, dashboards. Candidates must prioritize concerns under budget and time constraints, explaining trade-offs. Validates that architecture embeds these qualities from inception. Also evaluates how to design for compliance, GDPR, HIPAA, PCI DSS within .NET services. Architects must demonstrate how they balance these concerns within CI/CD pipelines. But here's where it gets interesting: workflow, the SANE-based interview process. A 90-minute structured session with 3 phases designed to simulate real architectural pressure. Phase 1, 45 min, business case presentation, initial architecture design on collaborative canvas. Phase 2, 30 min, constraint injection traffic 10x, data residency regulation, critical bug. Phase 3, 15 min, candidate retrospective, defending decisions and exploring alternatives. Multiple interviewers score independently using a calibrated rubric, then converge. Rubric dimensions, design rationale, 30 per trade-off clarity, 25 .NET technical depth, 25 communication, 20. All sessions are time-boxed and structured to reduce candidate anxiety while maximizing signal. Interviewers use a standardized scorecard with behavioral anchors for each dimension. So what's the real problem? Let's talk about impact. Precision architecture hiring. Adoption data, 60% reduction in architect mishires, 40% faster time to productivity. Vetted architects produce systems with measurably lower defect rates and higher evolvability. Hiring decisions are evidence-based, legally defensible, and bias mitigated. Teams report faster architectural decision-making and reduced friction in cross-team design reviews. Cost savings exceed $150K per senior hire when accounting for rework and turnover avoidance. The approach signals to candidates a mature, respectful engineering culture. Long-term retention of architects hired through this method is 35% higher than industry average. It reduces time to hire 25% by early elimination of unqualified candidates. This raises a critical question: future, adaptive, and continuous assessment. AI-driven scenario generation tailors challenges to candidate profile and specific role requirements. Remote-first collaboration platforms with digital whiteboards enable global async evaluations. Continuous feedback loops will correlate assessment scores with real-world architecture outcomes. Open source scenario libraries foster industry-wide benchmarking and community contributions. Integration with hiring platforms, Greenhouse, lever to automate workflow. The framework evolves alongside .NET innovations, minimal APIs, native AOT AI orchestration. Machine learning models will identify the highest signal scenario fragments for each competency. Community-driven scenario marketplace will accelerate adoption and domain-specific customization. Now let's zoom in on the new standard for .NET architecture hiring. Scenario-driven assessment is the industry's new benchmark for solution architect evaluation. It replaces subjective intuition with structured, repeatable signals. Organizations that adopt this approach build stronger, more resilient architecture teams. The framework and initial scenario set are available for adoption and contribution. Elevate your hiring from knowledge recall to architectural judgment. Join the community of practice. The era of guesswork in architecture hiring is over.